Today I would like to start talking with you about squaring and rooting. Do those words mean anything to you right now?
No.
The word square doesn't mean anything to you?
It's a square.
A square, right? What does squaring mean to you? If I square something, I multiply it by itself. That's a great definition for squaring. So what is rooting? Take the square root of something. What do those two things have to do with each other? Hey, they're inverses of each other. Look, squaring and rooting, inverses. Okay? So let's look at problem number 1. Let's review quadratic functions. It's a good thing that we just finished those, so we're just reviewing them, right? Because you all did decent. Kind of. All right? So for the equation y equals x squared, complete the table. Well, if it's y equals x squared, what is negative 3 squared? 9. What's negative 2 squared? Negative 1 squared? Wait, what did you say? Negative 1 squared? 1? Okay. 0 squared? 1? 2? 3. This is supposed to be a positive one. I don't know why I put a dot there. Look, I'll put a lot of dots. How about that? Does that work?
No.
Okay. Plot the points to construct the graph. Well, negative 3, 9. 1, 2, 3, 4. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. Can I connect these points?
Yes, you can.
How do you know I can? Because there is an equation right up here, right? If the domain of this equation is negative 3, negative 2, 1, 0, 1, 2, and 3, what is the range? Okay, so I have heard 4 answers that are all really good, but only one of them's right. Okay? The other 3 that I heard were very logical because I think hopefully you're basing it on stuff we've already talked about. One of them that I heard was all real numbers. Okay? If you have a defined domain, can your range be all real numbers? Has to match up with this domain that's given, right? So that's logical to a point, but not quite correct. Okay? Then I heard x is greater than or equal to 0. Well, that is a really great domain for this parabola. Excuse me. A really great range for this parabola. First of all, if it would be y is greater than or equal to 0, right? But once again, we're asking for specific domain values. Don't we need specific range values? The next one I heard was 9410149. Where did that come from? The y column. I read to you the domain of the x column, and you read to me the y column. Is that closer? Much closer, but when we write on our range, that's exactly right. We only write the numbers once, and we write them how? In order, greatest to least, or least to greatest? Least to greatest. So our range would be 0, 1, 4, 9. Good conversations, though. Good guesses. Sometimes you guys don't have really great guesses. I'm just being honest. Those were good guesses. Okay? Is this equation a function? Explain. Okay? Yes. I heard passes the vertical line test. And I also heard no repeating. I can't spell today, guys. I'm sorry. That's not me saying I don't have to know how to spell. I'm truly apologizing for not spelling correctly. Okay? So it's really good for us to know both of these definitions, right? The second one is probably where we're going to kind of focus today. Fair enough? Okay? So recall that an inverse can be formed by switching x and y, right? If you don't remember that, read the words switching x and y. Use this method to make the table in the graph for the inverse of y equals x squared. Look what they did with the x's. They put it in the y column. What do you think we should do with the y's? Put them in the x column. 9, 4, 1, 0, 1, 4, 9. Now plot those points. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. 1, 2, 3, 4, 2. 1, 1, 0, 0. 1, 1, 4, 2, and 1, 3. Tell me when you're done. Good job, team leaders. I'm seeing a lot of you looking at your tables and then looking at me to tell me that you're done. Thank you for that. Okay? Is this inverse a function? Nine is here. 9 is also here. 4 is here. 4 is also here. 1 is here. 1 is also here. No. X's repeat. Now, for people who like the graph more, look, does it pass the vertical line test? No, it's touching there and there. Okay? Any questions about that? Remember that another way to find an inverse, besides just switching x and y on a table or a graph, is to switch the x and y variables in the equation. If the first equation was y equals x squared, what is the inverse going to look like? Perfect. X equals y squared. How do you suppose we're going to get the y by itself? What is happening to the y right now? What's the inverse operation of that? The square root. Absolutely. So if I square root the y squared, what else do I have to do? I have to square root the x as well. I have to square root both sides, don't I? So what I get is y equals the square root of x. Look at this very strange looking notation. What is that? First of all, it is function notation. Do you see that little -1 right there? Is that an exponent? It looks like one, but it's not. Okay? It is saying we are talking about a function, but we're talking about the inverse. So when it's f of x, we're talking about the original equation.
Miss Kingston?
Yes, ma'am.
I need Farron Guston to come to the office. She is leaving.
Thank you. She's on her way.
Thank you.
F of x is the regular equation, right? If we have f of -1 of x, and honestly, I don't know if I'm saying that right. I just know we're still talking about a function, except we're talking about its inverse. We've switched x and y. Does that make sense? I apologize for not knowing how to say it right. I will talk to my friends in my class. I bet they know how to say it. They are super smart. Okay? But when you see f of x and it has that little baby -1 up there, I know for sure we don't say f of little baby -1. I know that's wrong. Okay? But please know we're talking about the inverse. Fair enough? So the inverse is the square root of x. So on a calculator, like for instance this calculator, if I put in y equals the square root of x, it looks like that, right? So I'm going to copy that to this graph right here. And I'm going to ask you a rather strange question. What did we do from problem number A here to problem number A here? I switched x and y. What did I do in problem number 3? I switched x and y. Look at their graphs. Do they match? Do they match?